Hello everyone, so this is going to be the mini lecture on parabolas, which parabolas have one of the two equations that you see on the screen there. A parabola can be written in the form y equals ax squared plus bx plus c, or another form that we can write the equation of a parabola in is y equals k times x minus a times x minus b. For the most part, we will be working with the second equation there, which is y equals k times x minus a times x minus b, because it's generally relatively easy to read the x-intercepts of the graph, which will be the values of a and b. So the most basic parabola would be the y equals x squared parabola. So that's why you might refer to y equals x squared as being the parent function for parabolas. So all parabolas are going to be that graph that you see on the screen there, that U-shaped thing, either stretched vertically or stretched horizontally or moved around left, right, up and down. So if we put a negative sign in the front of the equation, that has the effect of turning a parabola upside down. And that's quite usual in graphing, that if we put a negative sign in front of the function, it turns the whole graph upside down. So if we look at y equals x squared plus 1 now, so to the y equals x squared function, we've thrown in a plus 1. The effect of that is to move the graph up by 1 unit. If we instead throw in a minus 1, so x squared becomes x squared minus 1, that moves the whole graph down by 1 unit. If we want to shift the graph to the left, that means we need to replace the x with an x plus 1. So we need to put a plus 1 in a bracket with the x. And if we want to shift it in the other direction, shift it the other way, so shift it to the right, then we need to replace the x with an x minus 1. So throw a minus 1 in a bracket along with the x. And that's true for graphing in general. Just throw in a stray plus 1, that moves the graph up by 1. If we want to move a graph down by 5 units, we'd put a minus 5 at the end of the equation. If we want to move the graph, say, 10 units to the left, that means we're going to need to put a plus 10 in with the x inside a bracket, and moving it to the right by, say, 5 units is going to replace an x with x minus 5. So our most common task is going to be to find the equation of a parabola graph. So the best form to use here would be y equals k times x minus a times x minus b, because we can read the x-intercepts directly off the graph. So here we've got 3 and here we've got 1. Okay, so those are the two x-intercepts. So therefore we've got y is k multiplied by x minus 1 times x minus 3. Okay, so we have our x-intercepts, and we can now work out what k is. We need to find the value of k, which is a stretch factor. And to use the value of k, we can use any other point other than the x-intercepts. Easiest one to use here would be the y-intercept, which is y equals 3, and that's when x equals 0. So y is 3 is k times x is 0 minus 1, and x is 0 minus 3. So therefore, we've got 3 equals k multiplied by 0 minus 1 is negative 1, and 0 minus 3 is negative 3. And from that, we can work out what the value of k is, which is going to be minus 1 times minus 3 is going to be 3. So we've got 3 multiplied by k, so we've got 3 equals 3k, and therefore k equals 1, and your equation is y equals k is 1. If we substitute that back into y equals k times x minus 1 times x minus 3. We get 1 time, so we don't need to write a 1 time, so we get x minus 1, x minus 3. So that is our equation. And we were also asked about the line of symmetry, but we notice that it's going to be, any parabola is going to be symmetric about a line halfway between the two x-intercepts. So our x-intercepts are 1 and 3, and if we want halfway between them, that's going to be 2. If it's not so obvious where halfway between the x-intercepts is, add them together, so 1 plus 3, and then divide that answer by 2. Get the average of the x-intercepts, in other words. So 1 plus 3 is 4, divide by 2, we get 2 there. Okay, so if it's going to be symmetric around that line, assuming that that was a straight line, which it's not even close to, but if we picture that being a straight line, it would be symmetric about the line y equals 2. Sorry, that's x equals 2. Symmetric about x equals 2. A vertical line is x equals a constant. Now, if we also want to find the vertex, so for the vertex, what we need to do is, we know that the vertex is on our line of symmetry. The vertex, by the way, means the turning point. And if we substitute in x equals 2, we get our y value. Y is going to be equal to 2 minus 1 multiplied by 2 minus 3. So we're replacing the x's with 2. And if we calculate what we're going to end up with there, so we've got y equals 2 minus 1 is 1, and 2 minus 3 is negative 1. So we get negative 1, and we've got the coordinates of the vertex. So for the vertex, x is 2, y is negative 1. Okay, so let's have a look at the equation of what we see on the screen there. First thing we need to work out is the equation, the form of the equation, which is k times x minus a, x minus b, and we read what your x-intercepts are, which are negative 1 and 2. So our equation is going to be y equals k times x minus a, which is going to be x minus negative 1. Minus negative together like that becomes a plus, so that's x plus 1 multiplied by x minus 2. Okay, so we have our almost equation, but now we need to find the value of k. So we can find k by substituting in any point other than the x-intercepts. There are a couple of options here. We could use the y-intercept, which is x equals 0, y equals 2. So that would be that point there, y-intercept. Or we could even use the other point that we see, which is there, which is x equals 1, y equals 2. So both of those should give us the same value of k. And we notice that this parabola is upside down. And because it's upside down, we are expecting a negative value for k. So therefore, if we substitute in 0, 2, so x is 0, y is 2, we get 2 equals k times 0 plus 1, so we're replacing the x with 0, and 0 minus 2. So therefore 2 is going to be k times 1 times negative 2 if we work out what the brackets are, and 1 times negative 2 is negative 2. That's going to be multiplying k equals 2, and therefore k is 2 over negative 2, which is negative 1, and your equation is y equals negative of x plus 1 times x minus 2. So that's our equation. At that final step there, we take our value of k and put that back into the equation just after we'd found the x-intercepts. And as we predicted, we're getting a negative value of k there. Okay, so next question, what's the equation? So thinking back to what we were looking at before with the translation of the graphs, the parabola has been moved 1 unit to the left, which means we are expecting it to be something times x plus 1 squared. Let's look at the x-intercept. Now it's turning right on the x-axis here, which tells us firstly the form that we work with is k times x minus a times x minus b. Since it's turning right on the x-intercept, right on the x-axis, that means we can treat it as though we've got a double intercept at -1. So if we've got a double intercept at -1, we've got k times x minus -1, which is x plus 1, and it's a double intercept, so it's going to be the same for this bracket as well, x minus -1, which is x plus 1. And x plus 1 times x plus 1 is something times itself, which is going to be that thing squared. So that's going to be k times x plus 1 squared. Now what we'll need to do next is we will need to put in any other point. We've got a few options here. We could go with -2, 2, which should be that point, or we could go with the y-intercept, which is the easier option if it's available as an option. So x is 0, y is 2, and if we substitute that into our graph, we've got y is 2 equals k multiplied by x is 0 plus 1 squared. So therefore, we've got 2 equals k multiplied by 0 plus 1 is 1 squared, and that's going to be 1 squared is 1. And if we multiply that by k, then that's just going to give us k being 2. So our equation will take that value of k and put that back into that line. We get y equals 2 multiplied by x plus 1 squared. So that is our equation. Okay, so what about the equation of this thing? So we recognize firstly that we can read the x-intercepts off the graph, which is going to be k times x minus a times x minus b form, and our x-intercepts are going to be 0 and are going to be 2. So if we say that y equals k multiplied by x minus 0, so a is 0 for the first intercept and 2 for the second intercept. Now x minus 0 is x, so we can write this as y equals kx times x minus 2. Now to find the value of k, what happens if we substitute in our value of the y-intercept? Well, if we put in the y-intercept, we're going to get 0 on the left-hand side. And because the y-intercept is 0, since we know the x-intercept is 0, that means the y-intercept must also be 0. So y is 0. But if we put 0 into that right-hand side, we are going to end up with k times that 0 is going to give us, that x is going to give us 0. And we're going to get 0 equals 0k. Since 0k equals 0, we've just got 0 equals 0. Tells us nothing about the value of k. So that means that if an x-intercept is 0, we cannot use the y-intercept to find k. Need to use one other point. So the other point that we can use here is the vertex. We can see from the graph that when x equals 1, y is -3. So if we substitute that into our equation, what we've got so far, we've got -3 equals k multiplied by 1 multiplied by 1 minus 2. So therefore, we've got -3 equals k multiplied by 1 multiplied by -1. And 1 times -1 is -1. So therefore, we've got -3 equals -1 times k. And that tells us if we divide through that equation by -1, we get k equals 3 and our equation there. So we take this value of k, put it back into that line, we get y equals 3x multiplied by x minus 2. Okay, so next question. What's the equation of that thing? Now that's going to be a little bit trickier because we don't have any x-intercepts. But what we do notice about this thing is that it, instead of intercepting the x-axis, which is the line y equals 0, it instead intercepts the line y equals 2, which is that horizontal line there. And those x-intercepts are -1 and -2. So since we have worked out that it's intercepting a horizontal line at 2 points, that tells us that we can use the equation y equals x minus a, x minus b with a modification. And that's the modification there is instead of intercepting the line y equals 0, it's intercepting the line y equals 2, which means we need to throw a +2 into the end there. Okay, so our intercepts are going to be -1 and -2, which tells us a is -1, b is -2, and therefore our equation is k times x minus a is x minus -1 is x plus 1 times x plus 2 plus 2, and therefore, well, to work out what the value of k would be, we would need to have information about about one other point other than the two that we're given. Let's assume that this has a y-intercept of 4, so that's going through at 4. What would we do then? So y is 4 equals k times, so this would be y-intercept of 0 plus 1 and 0 plus 2 plus 2. So let's move that final plus 2 to the other side. So therefore we get 2 equals k times 0 plus 1 is 1, 0 plus 2 is 2, and therefore 2 equals 2k, and therefore k is 1. So our final equation here is y equals, so we know that the first bracket is going to be x plus 1. K is equal to 1 if we throw that back into that line of working. So the line before we substituted in the x values and the y values, we get x plus 1, because k is 1, don't need to write a 1 times an x plus 2, and we've got that plus 2 at the end there. Okay, so we've got the equation of that graph. Now lastly, we need to find the x-intercepts and the y-intercept. So that's going to be singular. There is only one y-intercept of a parabola of y equals x squared minus 7x plus 10. And first thing to do, let's get the y-intercept first, which is put in x equals 0. We get y equals 0 squared minus 7 times 0 plus 10, which is 10. So for the x-intercept, we make y equal to 0. So if we make y equal to 0, we've got 0 equals x squared minus 7x plus 10, and we need to solve that quadratic equation. But this one factorizes nicely, looking for two numbers that add to -7 and multiply to 10. So those two numbers would be -5 and -2. So if x minus 5 is 0, moving the 5 to the other side of that equation gives us 5. And if x minus 2 is 0, moving the 2 to the other side of that equation gives us x equals 2. So our two x-intercepts are 5 and 2. Okay, so that concludes the mini lecture on parabolas. Next mini lecture will be on cubics.